So, right now, let's have a deeper look at a number of factors that we've already discussed, at least in part. And admittedly, this is an expansion of the neuroanthropology combined with some of those qualities from the entropic brain. I don't know how much time any of us have spent in absolute darkness. Not much. Not much. And I don't know your recollections, but mine is that as a child, the dark, absolute dark, was a pretty powerful feeling. A pretty powerful feeling. You know, there are many of us, many kids, many of us that have to have a nightlight, that there is something evocative about darkness. And absolutely, in practices, some of them still being done today, the famous dark retreat, is when you go into an environment where there's no visual stimulation. Well, guess what? Our visual cortex starts to fill in the blank. It's called famously different things. One of my favorites is it's the prisoner's cinema. That in the past, people locked into dungeons for long periods of time, a horrible punishment, in the dark, that's quite well known, even famous at a certain level, that you begin to see things, even if your eyes are open or your eyes are closed, because there's no difference, it's complete darkness, you start to see light play, all kinds of geometrics, and you even start to see scenes as though it was a movie. It's called the prisoner's cinema. So, sustained darkness is very, very provocative for the brain. And if you can imagine, we'll call the prehistoric relatives of ours, spending long hours every day, sometimes in the cold season, I mean, go all the way up into, you know, like the Baltic areas, where you can have 20 hours of darkness and 4 hours of kind of gray, and then it's dark again, as well as freezing cold with snow. Where are you going to be? Well, you're going to be hiding in the cave, but you don't see anything. Wow, how provocative that must have been for the early human brain. So let's appreciate the fact that our brain, as it's developed, has a huge visual cortex. As a matter of fact, there's more geography dedicated in our brain to vision than any other particular function. So when we don't have enough coming in, the brain starts to create its own expression in light. I was recently told this. I don't know if it's true. I'll accept that it's true, but I don't know if it's exactly this number. That our visual cortex has the ability to generate or express over 16 million colors. But our eyeballs are only able to detect a very small range of those colors, which kind of makes sense, because for those of us that have done psychedelics or using the neurovisor or any kind of similar thing, or even you see colors that don't seem earthly. You see shades of pink that you've never ever seen before. So what I'd like you to consider as a provocative manipulator or stimulator of your brain today, my brain today, but also the prehistoric brain, is how does the brain respond to sustained darkness? And it does adapt, and it does create all sorts of lights and scenes. I would think it would be very difficult to interpret the difference of a nighttime sleeping dream to what we'll call waking dreams, and hypnagogic states and hypnopompic states. So we developed, in good part, experiencing long periods of darkness in caves. Next, let's think about caves and what they sound like.